Hello everybody, today is the first video I've uploaded on this channel detailing a machine learning project I'm working on. In this video, I'll be creating a cellular simulation of sorts using machine learning and neuroevolution. The environment will consist of cells and smaller red dots that are food. Any given cell wants to eat as much food as possible so that it can undergo mitosis and spread its genes to the next generation. If two cells collide, the smaller one is eaten by the larger one. This creates a natural selection-esque environment where the cells have to prioritize eating as much food as possible without being eaten themselves. Each cell is given a set of inputs to sense the environment around it. These inputs are a number of vision sensors around the cell's circumference that relay the distance to any object, as well as a value that correlates to the current size of the agent. The first step is to create the base classes and write the simple movement logic for the cells. Next, I wrote in a bit of code to make the cells burn energy at a constant rate, so it will eventually die if it chooses to simply remain still. Now we need to implement collisions between the cells and food objects. This is how the cells grow in size. With that out of the way, it's time to account for collisions between different cells. As stated earlier, the bigger cell will consume the smaller one. During this, I also updated the color scheme to be a bit more pleasing on the eyes. At this point, most of the simulation is done, so I imported the neural network library I made for a previous project and started working on the brain behind the cell's behavior. At this point, the next step in the project was to import a raycaster from another old project and determine which way to cast the vision lines that the cells use for input. All that's left is to process the output from the cell's brain, and we'll start seeing dynamic behavior in the simulation. Now onto the backbone of the mitosis algorithm. There were a few bugs in the wall collision code that needed to be fixed. Around here, I realized that the simulation was too slow for how many agents I had on the screen, so I spent a few hours off camera multi-threading the cell simulation portion of the code. The final touch was to render the cell a specific color based on the connections in its brain, demonstrating an aspect of speciation.